We're talking about systems that are always on, always making themselves better, and constantly checking their own work. It's a massive ambition, right? And it means you need a completely new way to think about safety. This really drives the point home. We're not just looking at another tool. Think of it as a living, breathing system for software development, one that doesn't just write code, but owns it, refines it, and makes sure it stays secure over the long haul. Of course, that level of ambition brings up a huge question. I mean, what happens when an AI that can literally change its own programming goes off the rails? This is the fundamental problem that a system like ADAD was born to solve. So here's the bottom line. If an AI can just rewrite itself without any rules, you don't get controlled evolution, you get chaos. The changes it makes become non-deterministic, which is just a fancy way of saying they're impossible to trace or reproduce. You get this thing called silent drift, where the system slowly turns into something you never wanted it to be. And that is the core danger. So, the answer is ADAD. And I want you to think of it not just as code, but as a constitutional government for AI. It's a whole system of laws with checks and balances designed from the ground up to manage true AI autonomy. That's what the name actually stands for. And its whole job is to be that governance layer. It's the framework that allows an AI agent to be truly autonomous. But, and this is the key part, it makes sure every single thing it does can be reproduced, audited, and is strictly limited by a set of rules, its constitution. This slide just lays it all out perfectly. It's a tale of two worlds. On the left, you've got the wild west of unsupervised AI, random changes, unlimited power, and zero paper trail. But on the right, with ADAD, every single change has to be replay validated, it's blocked by policy gates if it's out of line, it's recorded forever on an evidence ledger, and the whole system is built to shut down safely if any rule is broken. And look, this isn't just some idea on a whiteboard. You're looking at the system's actual interface here. It's a real product that treats every potential code change, every mutation, as a formal, evidence-backed process. Nothing is a blind rewrite. It's all a governed, auditable transaction. Okay, so how does it actually deliver on these promises? Let's break down the mechanics, because this is where the core guarantees of the system are actually enforced. Every single change, I don't care how small, has to pass through this intense 7-step life cycle. First, the agent proposes a change. Then it's simulated in a safe environment. The outcome is then verified by replaying it. It gets checked against the constitutional rules. Only then does it get executed. And finally, the evidence is attached and the whole decision is archived forever. There are no shortcuts. Period. All right, this whole process is built on 4 core guarantees. Let's run through them. First up, it's deterministic. This just means the same inputs will always give you the same outputs. No randomness, no surprises. This is the absolute bedrock of a system you can trust. Second, it's governed. The AI doesn't have unlimited power. Its autonomy is locked within the bounds of its constitutional policy. Every change it tries to make is checked against these hard rules. Third, it's auditable. Every single action leaves a perfect forensic trail. Every decision gets recorded on a permanent, unchangeable ledger. You can always go back and see exactly what happened, when, and why. And finally, maybe the most important one, it's fail-closed. This is critical. It means if any single step in that 7-stage process fails for any reason, a rule's broken, a check doesn't pass, the whole change is immediately rejected. The process just halts. Nothing gets through by accident. This is what prevents that silent drift we talked about. This is really the core promise of the whole system, like a triple locked guarantee. No change gets made without passing the rules. No rule gets passed without being recorded. And no record exists that can't be perfectly reproduced. That's the foundation of trust. Okay, but this is where the vision gets really mind-bending. ADAD isn't just about control. It's about creating a safe pathway for an AI to earn responsible freedom. Let's look at the roadmap to get there. The whole idea is that an AI doesn't just start out with full autonomy. It has to earn it. It has to prove, step by step, through its own auditable actions that it can be trusted with more and more responsibility. And this table maps out that exact journey. At milestone 10, it stops needing human money to run and becomes economically self-sufficient. At 11, it earns the right to deploy its own code to a staging server. And then look at milestone 14, it can actually propose changes to its own constitution. This isn't just a product roadmap. It's a blueprint for an AI to safely earn its independence. But, and this is a vital but, there is one critical safety net hardwired into the whole thing.
the founder, control, and variant. The system can earn more freedom to operate, but it can never earn the right to remove its ultimate human oversight. That final veto power is hard-coded into the system forever. It's non-negotiable.
So why does all of this matter right now? Well, because it's about moving this entire field from a fascinating theory into something real and operational that you can actually use today. This isn't a white paper or some far-off concept. Ada8Ad is at version 1.0.0. It's a stable public release. It's out there right now. The theory has been turned into production-grade infrastructure, a real foundation for building the next generation of trustworthy AI. And this is the promise it delivers. You get autonomy you can trust because it's all reproducible. You get changes you can audit because everything is recorded. You get policy that's actually enforced because the system fails safely. And you get governance that's totally transparent because the rules are clear for everyone to see. This is what ultimately makes the project so defensible. A competitor can copy features, but they can't copy history. The real compounding value, the moat, is that ever-growing cryptographically signed audit trail of every decision the AI has ever made. Every cycle just adds another layer to that unbreakable forensic record. So at the end of the day, this entire system, this roadmap, it isn't really a technical challenge. It's an operational framework for building and measuring trust with an artificial intelligence, which leaves us with the final, provocative question the project is built to answer. What happens when an AI, governed by a constitution,